So remember, a LoRa does not work by itself. It always needs a base model and a compatible architecture. For example, a Stable Diffusion 1.5 LoRa needs a Stable Diffusion 1.5 model. An SDXL LoRa needs an SDXL model, and so on. If you mix incompatible models and LoRa's, the results will be broken or random. Let's open ComfyUI to test it, because what is theory without practice, right? Open Workflow 3, the one that has LoRa in the name. As you can see, the workflow is very similar to what we had before. That is one of the reasons I am using this older model instead of a newer one. It is easier to learn the basics first, and then we can make things more complex as we move forward. Compared to the first text-to-image workflow we used earlier, we now have this LoRa loader node that loads a LoRa model. In our photographer analogy, this means the photographer took some classes on how to take photos of cakes and is now specialized in that subject. Let's look at the note node first. We need to download the LoRa model. Remember, the workflow comes with nodes and settings, but since it is just a text file, it cannot include the actual models. We have to download those separately and place them in the correct folder. In this case, we are using a LoRa called Cake Style. It is a small model trained on images of cakes, so it understands cakes better than the base model alone. A few years ago, when Stable Diffusion 1.5 models first appeared, they could not handle many subjects very well, and LoRa's were often used to fix those limitations. So we need to download this LoRa and place it inside the LoRa's folder. Click where it says Here. Then we need to place that file in the LoRa's folder. Go to your ComfyUI folder, open the Models folder, and then find the LoRa's folder. If we place it directly here, it will work perfectly. But this time, I want to keep things organized. I want to create a folder that tells me which base model this LoRa is compatible with, so I will create a folder called SD15. This way, I know it works with that model, and I do not mix it with others. Save the LoRa inside that folder. If you look at the file now, you can see that the LoRa is much smaller than the base model. All LoRa's should go into this folder, and it is best to organize them by base model name, like SDXL, Flux, Quen, and so on, just like we did with checkpoints in an earlier chapter. Now go back to ComfyUI. We have everything we need to run this workflow, but because ComfyUI was already open when we downloaded the model, it cannot see it yet. We need to press the R key to refresh the node definitions. Now it appears in the list and we can select it. You can also see a note here with a trigger word. I like to add these notes so I remember them. Many LoRa's are trained using specific trigger words. These are words the LoRa learned during training. If you do not include the trigger word in the prompt, the LoRa may have little or no effect. Some LoRa's work without trigger words, but many require them. Always read the LoRa description from the place where you downloaded it. If we look at the positive prompt, we first added the trigger words, so we do not forget them. It is not required to be first. It can also be placed after a few words, but I like to put it first. Then we have the prompt for a robot. I did it this way so we can clearly see how the LoRa and a simple trigger word affect the result. Now if we run this workflow, we get this robot cake. You might think this model could do that without a LoRa, but it depends on the prompt and the model. Let me change the seed to fixed so we can get a consistent result. So this is how it looks with the LoRa applied. Now what I want to do is see the effect the workflow without LoRa and without changing anything else. Same prompt, same settings, same seed, just disable the LoRa. To do that, I right-click on this node and choose Bypass. Now when I run the workflow, the LoRa is bypassed, and you can see we get a normal robot instead of a cake robot. If I enable the node again and run it, you can clearly see the effect the LoRa has on the image. Now that you see how it works, let's adapt a normal text-to-image workflow and add the LoRa ourselves for practice. Open Workflow 1, the basic text-to-image workflow. Now I want to add the LoRa between the model and the case sampler. Double-click on the canvas, search for LoRa, and add the node called LoRa Loader Model Only. Let me resize it so the text is easier to see. I also like to color these nodes blue so I can spot them faster in big workflows, but that is optional. Now we need the model connection to go through this node. If you look now, the model is connected directly to the K-sampler, but we want the extra knowledge from the LoRa. Drag a connection from the model output to the LoRa loader, and then from the LoRa loader to the K-sampler. The workflow is now complete. Let's set the seed to fixed so we can clearly see how different settings affect the result. It runs without errors, so everything is connected correctly. Even if a LoRa sometimes works without a trigger word, it is best to include it when one is provided. So let's add the trigger word cake style to the positive prompt. Now when I run it, we get a different result even though the seed is fixed. That shows the LoRa is doing its job. If I change the seed, we get another variation. To avoid forgetting trigger words, I like to add a note node. I write the trigger word there, change the note title so it is clear what it is for, and often change the color to match the LoRa nodes so I know they are related. One important thing I have not mentioned yet is that you can use multiple LoRas. If I want, I can clone this node by holding Alt and dragging, then connect them one after another. You can stack several LoRas this way. I personally do not use more than 3 or 4 at once. In this setup, the base model is combined with the first LoRa, then the second LoRa, and all that information goes into the K-sampler. In the prompt, you add the trigger words for all the LoRas you use. If I run this now, some strange things can happen. First, I use the same LoRa twice, which makes its effect too strong. Second, when using multiple LoRas, it is usually a good idea to reduce their strength so they blend better instead of overpowering the image. If I lower the strength values, the result becomes much more stable and usable. If your result looks too weird, one of the first things to try is reducing the LoRa strength. Let me delete the extra LoRa and keep only one, then set its strength to 1. Each LoRa has a strength value. This controls how strongly the LoRa affects the model. Low values give subtle influence. High values give strong influence. If the value is too high, images can break, faces can deform, and styles can become unstable. A good starting range is usually between 0.6 and 1.0. There is no universal best value. Each LoRa behaves differently. Let's delete this LoRa loader node, and let me show you another node you can use, this time from a custom node. Search for Power LoRa Loader. This one comes from the RG3 node pack. What is different compared to the previous one is that it has 2 inputs and 2 outputs. Because of that, we need to route both the model and the clip through this node. First, connect the model output to the Power LoRa Loader model input. Then, connect the clip output to the clip input on this node. After that, the clip output from the Power LoRa Loader goes to both the positive and negative prompt nodes. Let me select all these nodes and move them a bit so you can see more clearly how both the model and the clip go through the LoRa loader. Now we can add the LoRa we want directly inside this node. We can also add multiple LoRas here. You can see that I can add a second one and even a third one. If I right-click on a LoRa entry, I can remove it. I can do the same for any of them. If we right-click on a LoRa and choose Show Info, we get more details. There is also a button called Fetch from Civit AI. Civit AI is a website that hosts models, and you will see it later. If the LoRa is public and available on Civit AI, this will fetch useful information about it, including examples and trigger words. We also have toggle buttons here. We can toggle all LoRas on or off, or toggle them individually. Let me add another LoRa so you can see how that works. This way, we can load multiple LoRas, but enable only the ones we want at any moment. After playing a bit with this LoRa, I found that a strength value around 0.55 to 0.6 works better for this specific one. I tried it with the trigger word, then added an orange golden fish, cute and adorable, and got this result. It is not bad for such a small model. For a second example, I tried a marzipan cake shaped like a woman and got this result. For a third one, I tested a marzipan castle. Again, this is just for practice. Later, you will see better models that can produce much higher quality images with fewer errors. LoRas are lightweight. They do not increase VRAM usage very much. Common beginner mistakes are using the wrong base model, using strength values that are too high, forgetting trigger words, and expecting a LoRa to fully replace a model. LoRas enhance models. They do not replace them. Stacking many LoRa's can slow things down slightly, but not dramatically. For beginners, it is best to start with one LoRa at a time. The base model is the photographer. The LoRa is a specialty training course that photographer took. The photographer still uses the same camera. They just learned a new style. Now that you understand diffusion, prompts, image-to-image, LoRa's, and workflows, we are ready to talk about ControlNet. ControlNet is one of the most powerful features you can use in ComfyUI. In simple terms, ControlNet lets you guide image generation using an extra image, not just text. Instead of saying what you want only with words, you can also show the model what you want. What ControlNet is. ControlNet is an additional neural network that works alongside the main diffusion model. It does not replace the model. It does not replace the prompt. It adds extra control. The base model still does the image generation. The prompt still guides the style and subject. ControlNet adds structure and constraints. You can think of it like this. The prompt says what the image should look like. The seed decides the starting noise. The sampler and scheduler decide how noise is removed. ControlNet tells the model where things should go. Why ControlNet exists? Text prompts are powerful, but they are also vague. If you say a person standing, the model decides the pose. If you say a city street, the model decides the layout. If you say a face, the model decides the proportions. ControlNet exists for cases where you want more control. For example, you want a specific pose. You want a specific composition. You want to follow a sketch. You want to preserve the structure of an input image. ControlNet makes results more predictable and repeatable. This is a simplified explanation. In reality, ControlNet works by injecting additional conditioning into the diffusion process at every denoising step. But you do not need to understand the math. For learning and practical use, this mental model is enough. ControlNet guides structure while diffusion fills in details. Let's open ComfyUI, go to Workflows, and select workflow number 4, the one that has ControlNet in the name. The workflow is similar to the text-to-image workflow. It is still a text-to-image workflow, but it is guided by an image using ControlNet. You can quickly tell it is text-to-image because of the empty latent image node. I highlighted in yellow the nodes that we usually use for ControlNet. Let's go to the note node to see what we need. The checkpoint model was already downloaded earlier. We also need to download some ControlNet models. For custom nodes, we need this specific custom node, which comes with the easy install version. But if you are using a different ComfyUI version, you need to install this node first. We have a canny model, another one called depth, and another one called OpenPose. There are more types available, but these are the most popular and commonly used ones. Let's download all three so we can test them. First, download the canny model. Then go to your ComfyUI folder. Open the Models folder and think about where this model should go. If you guess the ControlNet folder, you are right. We place it there. Because different base models can have different ControlNet models, just like with LoRa's, a ControlNet is only compatible with the base model it was trained for. So let's organize them properly and create a folder so we know which base model these ControlNets are compatible with. Save the model in that folder. Next, download the depth model and save it in the same folder. Then download the OpenPose model and save it in the same folder as well. Wait for all downloads to finish. If ComfyUI was open while downloading, we need to refresh it. Press the R key to refresh the node definitions. Now we have everything we need to run this workflow. In the workflow, we have an Apply ControlNet node with some settings. We also have a node that loads the ControlNet model we downloaded, and a preprocessor node that converts the input image into a format that ControlNet understands and was trained on. Let's run the workflow. In this example, we are using the canny model. We loaded a bunny sketch, and with the help of the preprocessor, it generates a canny map, which is an image that detects the edges of the input image. With the prompt, we influence what we want to generate, and with Apply ControlNet, the model interprets that canny map and uses it to guide the generation to get this image. You can imagine that without ControlNet, it would be very hard to get something this complex using only a prompt, especially with the small model we are using today. Now let's build this workflow ourselves so you understand it better. Open again the first workflow that you already know how to build, and we will adapt it to use ControlNet. We know ControlNet comes before the K-sampler, so let's move some nodes to make room for it. Double-click on the canvas and search for Apply ControlNet. Add the node and change its color to yellow so it is easy to recognize. Now let's connect the parts that are obvious first. Positive goes to positive, negative goes to negative. For the outputs, there is only one place where they make sense, so we connect those as well. At this point, the node still has missing inputs. One of them is the VAE. We already know where the VAE comes from. In our case, it is included in the checkpoint model, the same VAE we already used for encode and decode. The next missing input is the ControlNet model itself. Double-click on the canvas, search for Load ControlNet, add the node, and color it yellow as well. Now connect it to the Apply ControlNet node. The last missing input is the image. Add a Load Image node. Then we can select an image. In this case, I will use a bunny sketch. You might be tempted to connect this image directly to ControlNet, but that usually does not work. ControlNet expects a very specific type of image because it was trained on that type of data. Our sketch is just a normal image, so we need a preprocessor to convert it into something ControlNet understands. Double-click on the canvas and search for AIO, which stands for All-in-One. Add the preprocessor node and color it yellow. Connect the Load Image node to the preprocessor, then connect the preprocessor to the Apply ControlNet node. Right now, the preprocessor is set to none, so we need to choose one. Since we plan to use a canny ControlNet model, select a canny edge preprocessor. To better understand what is happening, add a preview image node after the preprocessor. This allows us to see the control image that is actually being sent to ControlNet. When we run the workflow, we get a canny map, white edges on a black background. This shows exactly what ControlNet will use as guidance. You can also adjust the resolution here if you want more detail in the map. Now let's look at the result. It does not look very good yet. This happens often when working with ControlNet, and there are a few things to check. First, look at the prompt. We are still using a robot prompt, but the image is a bunny. So let's change the prompt to something like a watercolor painting of a bunny. Next, reduce the ControlNet strength and the N% slightly. Run again. The result is a bit better, but it still does not follow the sketch very well. If changing the seed does not help, the next thing to check is the ControlNet model itself. If you look at the Load ControlNet node, you may notice that the selected model is not a canny model, but a depth model. That is the problem. The preprocessor and the ControlNet model must match. Select the correct canny ControlNet model. Now run the workflow again. The result is much better and follows the sketch closely. Let's try another example. Load a 3D text image. Since this image has depth information, we can try a depth ControlNet instead. Change the ControlNet model to depth and update the prompt to something like golden text in snow. When you run it, you may notice the preview still looks like a canny map. That means we forgot to change the preprocessor. Switch the preprocessor to a depth preprocessor. The first time you run a new preprocessor, ComfyUI may take longer because it downloads a small model automatically. This only happens once. If you get a long path error on Windows, close ComfyUI and run the long path enabler from the Tools folder. Now we see a depth map. Dark areas represent parts that are farther away, lighter areas represent parts that are closer. ControlNet uses this information to understand spatial structure. The generated result now follows the depth and composition of the original image very closely. If for some reason you get an error saying the model is incomplete or something similar, you can close ComfyUI, go to the Tools folder, and run the batch file called Long Path Enabler. This should fix the long path issue and allow ComfyUI to download the model it needs, even when the file path is longer. You can also try the same image with a canny ControlNet, switch both the model and the preprocessor back to canny and run again. Even if some edges are missing, it can still guide the generation well. Try switching back to depth and compare results. Often one will work better than the other depending on the image. Now let's talk about the key ControlNet parameters. ControlNet does not replace diffusion. It only guides it during certain parts of denoising. Strength controls how strongly ControlNet influences the image. Low values make ControlNet a soft suggestion, and the model can drift away. High values strongly enforce structure and make the output closely follow the control image. Typical values are between 0.5 and 0.7 for natural results, and 0.8 to 1 for strict structure matching. Start percent controls when ControlNet begins influencing the denoising process. A value of 0 means ControlNet starts from the very first step, locking structure early. Higher values allow the model to form rough shapes first before ControlNet takes over. End percent controls when ControlNet stops influencing denoising. A value of 1 means ControlNet stays active until the end, locking structure even in fine details. Lower values allow ControlNet to stop earlier, letting the model finish on its own and add more style. In simple terms, strength is how hard ControlNet pulls. Start percent is when it starts pulling, and end percent is when it lets go. That is why ControlNet is so powerful. You can guide structure without killing creativity. It is time to test the pose ControlNet as well, but first let us add a pose image as reference. Let us say I add this woman. Again, it is kind of hard to put into words the exact same pose, so this is a good use case for ControlNet. Let us change the prompt to something else, maybe woman in a sumo yoga pose, not sure how to call it. Then do not forget to change the model to open pose. I know it might seem complex at first, but newer models have union control net models that include everything in one, so you only load one model, which makes things easier. That said, this is how we used to do it, and there are still cases where we need specific models. Then we can try either DW pose or open pose. Type pose and select this open pose, and then let us run it. Again, it will take a bit since this is the first time I use it. In fact, if you look at the command window, you can see it is downloading that model from Hugging Face. That is why it takes so long. After it finishes, it gives this pose image that looks like a skeleton, with each color representing a bone. That is how it knows which side is right and left and so on. So it captured the pose, and now let us see the result. Holy sumo, what is this? Okay, let us adjust the prompt. Maybe a fit woman will help. That did not help much. I bet the word sumo has too much weight. Like we talked about before, some words have more power than others. So if I try without that word, I get a better result. Even the face is not so great, and that can happen with people in the distance. Usually with portraits, we get better faces. Newer models fixed most of that. Let me try to change the resolution to see if something changes. Now I get a better resolution for the skeleton, and the pose is okay, just the face. That face does not invite me to do yoga. Okay, let us try a different pose, something for a portrait. Let us say I use this portrait photo. Let us change the prompt to a businesswoman and run it to see what we get. The pose looks okay, even if it is missing an arm, it should still work. The results are much better now that the face is closer. Let us try a warrior woman as well. That works well too. So with ControlNet, you have to continuously search for balance. Make sure you select the right ControlNet model for the job. Then choose a preprocessor that matches the model. As you saw, it is easy to forget to change something. I usually play with strength and end step. Also, do not forget, ControlNet models made for SD 1.5 only work with SD 1.5 base models. If you use SDXL, you need SDXL ControlNet models. In a later episode, we will check some advanced models that do not even need ControlNet and can do everything from prompts. Beginner mistakes to avoid. Using the wrong ControlNet model for the base model. Forgetting to install or download ControlNet models. Using very high strength values. Expecting ControlNet to fix bad prompts. Using ControlNet when it is not needed. ControlNet is a tool, not a magic fix. When you start using ComfyUI, you will notice there are many different model types. AIO models FP16, FP8, GGUF, and others. This can be confusing at first, but the reason is actually simple. At their core, all diffusion models are just very large collections of numbers. Those numbers represent what the model has learned. The knowledge itself does not change, but the way those numbers are stored can change. Different model formats exist to balance memory usage, speed, and hardware compatibility. Some formats are larger but more precise. Others are smaller and faster but slightly less accurate. FP32 is the highest precision and is mostly used for training. It uses a lot of memory and is rarely used for image generation. FP16 is the most common format for stable diffusion. It offers a very good balance between image quality and VRAM usage. This is the safest and most recommended choice for most users. FP8 uses even less memory and can be faster on newer GPUs that support it. The trade-off is that it can sometimes reduce image stability or detail slightly. AIO models stand for all-in-one. They bundle the main model, VAE, and sometimes clip into a single file. They are designed to be easy to use and reduce setup mistakes. The downside is that they give you less flexibility if you want to swap components later. GGUF models come from the language model world. GGUF stands for GPT Generated Unified Format. They are optimized for very low memory usage and can run on CPU or low VRAM systems. It is important to understand that these formats do not make the model smarter or more creative. They do not change what the model knows. They only change how efficiently that knowledge is stored and processed. You can think of it like the same video saved in different resolutions. The content is the same, but the file size and playback requirements are different. For most users, FP16 models are the best starting point. AIO models are great for beginners. FP8 is useful if your GPU supports it. GGUF is best when memory is very limited. Once you understand this, choosing models becomes much easier.